Today's objective, the real number system. What I'm going to do is I'm going to show each board for 5 seconds so you can write your notes down, and then I'm going to go through them one by one, okay? So here's the first one. Okay, so you should have a chance to pause everything and to write all your notes down. So let's go through the real number system objective. Let's go over some definitions. All right, irrational numbers. These are numbers that cannot be expressed as a fraction. They cannot be expressed. So those examples would be where they would be non-repeating and non-terminating type of decimals. Non-repeating, non-terminating. Rational numbers. Numbers that can be expressed as a fraction. So those examples would be fractions, repeating and terminating decimals, integers, whole numbers, and natural numbers. So looking at integers, let's remember back, what do the integers look like? They are whole numbers and their opposites. Whole numbers are natural numbers including 0. So they start with 0, 1, 2, 3, all the way up. Natural numbers, think about natural numbers as your counting numbers. It is natural when we start with 1. So 0 is not included in that. Inequalities. It's a math sentence that compares the value of two expressions using the inequality symbols. Less than, greater than, or equal to. So here's a Venn diagram for you. And our whole number set that we're dealing with is classified as real numbers. Okay? So we have two subsets. There's two different subsets in the real number system, classified as rational numbers and irrational numbers. So let's talk about the irrational. Remember before in the definition of how we described that. It cannot be written as a fraction. And those are called non-terminating and non-ending. There's no pattern. They don't end type of decimals. So here's some examples, like the square root of 2. That is not a perfect square. And when you, if you would type that into the calculator, then you would know that it just keeps going. The dot, dot, dot. It's just approximate to. There's no exact. We would have to type everything out to put an equal sign there. Square root of 7, another non-perfect square. And that is what that would look like. And then the symbol that we are definitely all aware of, the symbol pi. And we know that pi never ends, never repeats, there's no pattern in it. And so that would be classified as irrational numbers. Let's go over to rational numbers. Here's some examples here in those forms. So remember, integers, whole numbers, and natural numbers. You had that written down in your examples. And so here's some examples for each part of those subsets. And notice here we start into the natural, and natural is a subset of whole. Whole and natural are a subset of integers, and it just builds to that. So we're going to classify some of these numbers, okay? And remember, refer back to the Venn diagram as we're going through these so you can see where these are coming from. So let's name the sets or set of numbers to which each number belongs. Okay, so negative 17 over 31. That is a fraction. It does have a negative value, so we know that that is rational, therefore is a real number. Okay, number 2, the number 23. That is a natural number. It is also a whole number, therefore is an integer. It's also in the rational world, and it's a real number, because a whole number, all whole numbers can be written as a fraction by putting a 1 under it. The number 0. Now remember, it's not in the natural number set. That starts with the number 1. So it's a whole number, an integer, rational, therefore it's real. The square root of 2. Now remember, this is not a perfect square, and we'll learn about perfect squares a little later in detail. But when we type this up, we know that it is not ending. It doesn't end. It doesn't repeat. Therefore, it's irrational, real number. 3.14. A lot of you would get this confused with the symbol pi, but this is not being represented or used for pi. This is 3.14. It is a terminating decimal. There's no dot, dot, dot. Therefore, it's rational, and it's a real number. Now, the square root of 36. That is a perfect square, because 6 times 6 is 36. So that would equal a whole number. So when we classify it, it's natural, whole number, integer, irrational, and real. So now we're going to take some of these numbers and we're going to order them and compare particular numbers. So write in order form from least to greatest. Okay? So I have -3/8, -1/2, and -5/12. The key thing here is to know we're dealing with negative numbers. Okay? So here I have -3/8, and it's good. We can compare them as fractions, or it's just easier sometimes to go ahead and put them in decimal form to see their place values a lot easier. So when I convert this one to a decimal, I get -0.375. -1/2 is -0.5, and then -5/12 is -0.416. So you notice, looking at the place values, keep in mind we're dealing with negatives, okay? So that would give me, okay, remember negatives the farther away, all right, higher number the farther away from 0. So from least to greatest, I know that -1/2 is farthest away, so it's definitely the lesser number, and it would become in this order, all right? Problem number 2, least to greatest as well, and I have 2 fraction forms and a decimal. But if you notice the format of these fractions, we can definitely convert them to decimal form. So I have 1/3. We know that that is 0.333, repeating. 3 is repeating. 3/10 is 0.3, and 0.33 is already in decimal form. And so when you line up your place values, we definitely, it's easier to look at each place value to see which one is lesser and which one is the greatest. Okay? So we definitely see 0.3, 0.33, and then 0.333 repeating. Okay? And we would put those from least to greatest in that form. Now let's compare some fractions or decimals. Okay? So here I have 2/3 and 1/6. Now converting 2/3 and 1/6 to decimal form, I get this. But I also, if you remember back when, that you can also compare fractions by cross multiplying. So 6 and 2 gives me 12, and 3 and 1 give me a 3. And remember, the higher number, when you multiply, is also going to correspond to, that is the higher fraction. So I know the greater than is going to be towards the 2/3. So 2/3 is greater than 1/6. So let's look at this one. 3/5 and 0.6. I also can convert 0.6 to 6/10. So I know that 0.6 is also 6/10. So when I compare 3/5 and 6/10, comparing fraction form, 10 times 3 is 30. 5 times 6 is 30. So 30 does equal 30. So I know that they are both equal. They're the same. They're just in different formats, fraction form and a decimal form. They're the same number. All right, here. I have -2/3 and -1/6. This is very similar to the number 1 example that we had. So 6 times -2 is -12. 3 times -1 is -3. Again, keep in mind we're dealing with negatives, okay? So that would tell me that -1/6 is the bigger one, is greater than that one. So I would use the less than, because -2/3 is less than 1/6.